Today is real number system. So real numbers are simply the combination of rational and irrational number. In the number system, in the general, all the arithmetic operation can be performed on these numbers and they can be represented in the number lane. Also, at the same time, the imaginary number are the in real numbers which can be expressed in the numbers lane and is commonly used to represent in complex number. The concept related to real numbers are explained here in details along with examples and practice questions. The key concept in the number system is included in this article. So here are examples. 23, negative 12, 6.99, 5 over 2, pi 3.14. So definitions of real numbers. So real numbers can be defined as the unions of both the rationals and irrational numbers. They can be both positive or negative and are denote, denoted by the symbol R. All the natural numbers, decimals, and fractions can under this category. See the figures given below, which allow the classification of real number. So, real number definition. Rational 5 over 3, 0.63, 0.012. So, in the set of integers, negative 2, negative 1, 0, 1, 2. The set of all 0, 1, 2, 3, and so on and so forth. So the set of natural 1, 2, 3, and so on and so forth. So the irrationals, the root, the square root of 3 pi 0.10100110. So set of real numbers. The set of real numbers consists of different categories such as naturals and whole numbers, integers, rational and irrational numbers. In the table given below, all these numbers are defined with examples. So here are categories. So natural numbers. So the natural numbers contain all counting numbers which start from 1 and 1, 2, 3, 4, 5, and so on and so forth. For examples, all numbers such as 1, 2, 3, 4, 5, 6, 7, 8, and so on and so forth. So the whole numbers collections of zero and numbers and natural numbers W. So start from 0, 1, 2, 3, 4, 5, 6, and so on and so forth. So for example of whole numbers, all numbers include 0 as 0, 1, 2, 3, 4, 5, 6, 7, 8, and so on and so forth. So the integers. So the integers, the collective result of whole numbers and negative of all natural numbers. So example includes negative infinity start as negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4 plus infinitely. So the irrational numbers that can be written in the form of p over q. Oh, q is not uh, equal to 0. So examples of rational numbers are 1 half and 5 over 4 and 12 over 6 and etc. So irrational numbers, all the numbers which are not rational and cannot be written in the form of q over p over q. So examples, irrational numbers, non-terminating and non-repeating in naturals like square root 2. Real number charts. So the charts of set of real numbers include all types of given below. So real number chart. So real numbers include rational numbers and irrational numbers. So irrational numbers compress non-integers, rational numbers, and integers. So integers compose negative numbers and whole numbers. So whole numbers include zero and natural numbers. Properties of real numbers. There are four main properties which include commutative property, associative property, distributive property, and identity property. So consider and M, N, and R are three real numbers. Then above properties can be described using M, N, and R as shown below. So community property. If M and N are those numbers, then the general forms will be M plus N equals N plus M for additional, and M times N equals N times M for multiplication. So additional, M plus N equals N plus M. For examples, 5 plus 3 equals 3 plus 5, and 2 plus 4 equals 4 plus 2. So multiplications, M times N equals N times M. For example of multiplications, 5 times 3 equals 3 times 5, 2 times 4 equals 4 times 2. So associative property, if M and R are the numbers, the general form will be M plus open parenthesis N plus R close parenthesis equals M plus N plus R. For additional, M and N equals M in R for multiplication. So additional, so the general form will be M plus N plus R equals M plus N plus R. So examples of addi- additive associative property is 10 plus 3 plus 2 equals 10 plus 3 plus 2. So multiplication, M n R equals M in R. Examples of of a multiplicative associative property is 2 times 3 4 equals 2 3 times 4. So here are distributive property for three numbers M, N, and R which are real in naturals. In distributive property in represented as M n plus R equals Mn plus Mr, and M plus N equals Mr plus Nr. Examples of distributive property is 5 2 plus 3 equals 5 plus 2 plus 3 plus 5 equal times 3. Here's both side with yield 25. Identity property. So there are additive and multiplicative identities. For additional, M plus 0 equals M. 0 is additive identity. So for multiplications, M times 1 equals 1 times N. M equals M. So 1 is the multiplicative identity. So again, what are naturals and real numbers? So natural numbers are all the positive integers start from 1 to identity. All the natural numbers are integers, but not all the integers are natural numbers. There are the set of all counting numbers such as 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on and so forth. So Real numbers are the numbers which include both rational and irrational numbers. Rational numbers such as integers, so negative 2, 0, 1, 1. Fractions 1 over 2 and 2.5. And irrational numbers such as square root 3, pi, 22 over 7, and etc. are all real numbers. So, is 0 a real or an imaginary number ba siya? So, 0 is considered as both a real and imaginary number. As we all know, imaginary number are the square root of non-positive real numbers, and since 0 is always a non-positive numbers, therefore it fulfills the criteria of imaginary number, whereas 0 is always a rational number which is defined in a numbers lane and hence are real numbers. So are are there real numbers that are not rationals or rational ba siya? So no, there are no real numbers which are neither rational is rational. The definitions of real numbers in itself state that it is combinations of both rational and irrational number. So, is the real number is subset of the complex numbers? Ba na siya? So, yes, because a complex number is the combination of a real and imaginary number. So, if the complex number is a set, then the real and imaginary number are the subset of it. That's all. Thank you.